Bismillah, in this video we will solve some examples on the probability. The first one, the Ocean View Hotel has 300 rooms numbered from 100 to 399. A room is chosen at random. Find the probability that the room number ends in 0. From 100 to 399, how many numbers end with 0? To find the probability, we need to find how many numbers end with 0 over total, which is 300. Number end with 0, 100, 110, 120, 130, 140, till 390. If we count, we will find that this number 30, because from 100 to 190 we have 10, 200 to 190 we have 10, from 290 to 390 we have 10, so we have 30 over total 300. So probability equal 30 over 300. We can simplify to 1 over 10. Second one, two spinners have sections numbered from 1 to 5. Each is spun once and each number is equally likely. The possibility diagram is shown below. First spinner, second spinner. First spinner 1, 2, 3, 4, 5. Second 1, 2, 3, 4, 5. Now we have all the possibilities. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. This means 1 on the first spinner and 1 on the second. 1 on the first, 2 on the second, and so on. So this is all the possibilities, all outcomes for this experiment. Find the probability that both spinners show the same number. So it means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. How many? 5. And the total 25. We have 25 outcomes. So the probability number over total, which is 5 over 25, we can simplify to 1 over 5. B, the sum of the numbers shown on the two spinners is 7. Sum 7. So we have sum 7, 2, 5, 3, 4, 4, 3, 5, 2. We have 4 outcomes. So 4 over 25. The third one, a box contains 3 red pencils and 2 blue pencils and 4 green pencils. Raj chooses 2 pencils at random without replacement. Calculate the probability that they are both red. So red and red. For the first one, number of red, we have 3 red, and the total 3 plus 2, 5, 5 plus 4, 9. So 3 red out of 9. So for the first one, 3 out of 9, because we chose 1 from 3. So the probability for the first one, 3 out of 9. Red and red, so we must multiply, because this without replacement. So after we take 1 red, we have 2. So the probability for the second 2, and the total becomes 8. So 2 over 8. Then you can multiply to get 6 over 72. And you can simplify later. 1 over 12. B, they are both the same color. This means red, red, or blue, blue, or green, green. For red, red, we find, which is 1 over 12, plus we need 2 blue. So 2 over 9 times 1 over 8. Or 2 green, which is 4 over 9 times 3 over 8. Then we find the answer. 5 over 18. For C, exactly one of the two pencils is green. So red green, blue green. Exactly one is green, maybe red green or green red. Red green, or we can find red green multiply by 2. Red green, so 3 over 9. Green, which is 4 over 8. It's better to multiply by 2. So this means red green or green red. Or this means plus blue green or green blue. Blue green 2 over 9 times 4 over 8 times 2, because maybe blue green or green blue. Then we find the answer. Next one. When Ivan goes to the school in winter, the probability that he wears a hat 5 over 8. If he wears a hat, the probability that he wears a scarf is 2 over 3. If he doesn't wear a hat, the probability that he wears a scarf 1 over 6. Complete the tree diagram. How to complete the tree diagram? Probability of wearing a hat 5 over 8. So write 5 over 8. So probability of not 1 minus 5 over 8, which is 3 over 8. Now probability he wears a scarf 2 over 3. So write 2 over 3. So not 1 minus 2 over 3, which is 1 over 3. If he don't wear a hat, the probability that he wears a scarf 1 over 6. So 1 over 6 in this branch. So 1 minus 1 over 6, which is 5 over 6. These two branches must be 1, and these two branches must be 1. These two branches at 1. Now find the probability that Ivan doesn't wear a hat and doesn't wear a scarf. Not hat, no hat, and no scarf. So multiply these two branches. No hat, no scarf, so 3 over 8 multiply 5 over 6. 3 over 8 multiply 5 over 6. Double I wears a hat but doesn't wear a scarf. So hat and no scarf. Hat and no scarf. So 5 over 8 multiply 1 over 3. 5 over 8 multiply 1 over 3. Triple I wears a hat or a scarf, but not both. Not both means 1 minus both. 1 minus hat and scarf. So 1 minus hat and a scarf. So 5 over 8 times 2 over 3. So 1 minus 5 over 8 times 2 over 3. See, if Ivan wears a hat and a scarf, the probability that wears gloves is 7 over 10. Calculate the probability that Ivan doesn't wear all three of hat, scarf, and gloves. Doesn't wear all. This means 1 minus wears all. So 1 minus hat, scarf, and gloves. 1 minus 5 over 8 to wear hat times 2 over 3 for scarf times 7 over 10 this for gloves. 7 over 10. So 1 minus this. Then you can find the answer. Next, Pretty picks a card at random from the 11 cards above and it doesn't replace it. She then picks a second card at random and doesn't replace it. Find the probability that she picks the letter L and then letter G. Letter L. L then G. Probability of L one time. So 1 over 11 times probability of G one time, but total now 10, so 1 over 10 because doesn't replace or without replacement. So 1 over 11 times 1 over 10. And you can get the answer. The letter E, double I, the letter E twice. Letter E, how many times letter E? 1, 2, 3. For the first one, probability for the first one, 3 over 11. For the second one, minus 1, so 2 over 10. Triple I, two letters that are the same. Two letters are the same, maybe 2 E's or 2 N. 2E we find it before was 3 over 11 times 2 over 10. 2N, N twice, so 2 over 11 times 1 over 10.